Hey, welcome to the video. Today I'm just going to demonstrate how to differentiate an ellipse. So the typical formula for an ellipse is x over a squared plus y over b squared. And it's best to differentiate it implicitly, so ddx of the one side is, let's multiply that, x squared over a squared plus y squared over b squared equals to the differentiation of the other side, so ddx of 1. So here we have the product rule. We just differentiate the arguments in the bracket, which is x squared over a squared, and ddx of y squared over b squared. And we know the differential of a constant is 0. We want ddx of y to be the subject of our formula. So let's take this side. Remember that the differential, now let's take the constant out first, since it's 1 over a constant. Taking it this side, it becomes negative 1 over a squared multiplied by dx of x squared. And then this side, this argument here, we want to differentiate implicitly. So again, we can remove the constant, which is 1 over b squared, and leave the dx of y squared. At this point, we can take 1 over b squared to the right side by multiplying both sides with b squared, which will end up with minus b squared over a squared ddx of x squared. Let's differentiate this since we have the opportunity here. ddx of x squared is 2x. And let's focus on what's happening here. We're left with ddx of y squared, which is, if we apply the chain rule, it's 2y multiplied by ddx of y. If you don't know your rules, I recommend you go check out the previous videos on differential rules and implicit differentiation. I think they'll help. So now that we have this, we can divide both sides by 2y to make ddx. Actually, I can write this as dy dx. So I want to make dy dx the subject of the formula. Divide by 2y there, divide by 2y here, and we have minus b squared 2x over a squared 2y. These two here, that 2 and this 2 will cancel out, and we'll end up with minus b squared x over a squared y. And that's our differentiation of an ellipse. Hope that helped. Bye.